right, so the other day I mentioned that we were going to go through and look at the solutions to this problem. So hopefully you had a chance to do that. If not, you can write it down or get the solutions, do it, and check what you get later. So it says 14 volts are randomly selected from a normal population with standard deviation 0.08. The mean width is found to be 1.24 centimeters. Okay, so I'm not going to spend a lot of time on this. But just going through this briefly, hopefully this coincides with what you have. The point estimate is 1.24 centimeters, just X bar. If you're thinking too hard about a point estimate, you're probably not doing it right. Number two, I don't remember what confidence level this was, so I guess it's 1.96, so it must be 95, right? So the Z interval, because remember we're given sigma. If you go look at the way the problem is phrased, the standard deviation that's given is sigma. And by the way, somebody asked about that the other day. That's really the most important thing in the first part of this unit, is being able to read the problem and decide, am I being given sigma or am I being given S? That's a really big distinction, because once you get that, the rest of it's just kind of plugging in. So the margin of error, so by the way, we use 1.96 because it's a Z interval because we know sigma, so we use the Z critical value. So it's 1.24 plus or minus 0.0419. This 0.0419 would be called the margin of error. And so that's our confidence interval, our 95% confidence interval from you. In terms of assumptions, X bar normal, yeah, the population is normal implies that X bar is normal. SRS was given, sigma known, that was given in the problem. And then the question, we're supposed to decide if 1.2 is a reasonable value or something to that effect, right? That was the question. And 1.2 shows up in the interval, so we'd say yes, it's a reasonable value. Any questions on that?
So you wouldn't subtract it?
If it's within the interval, if it's reasonable, there's no MVD.
Oh.
MVD is only if you actually think it's unreasonable or different or something like that. Yeah. Because I think the follow-up question said something like, if it's not reasonable, how different do you think it is? Well, it is reasonable, so we don't have to address that.
Now, where it's indicated by saying that it's a normal population, would we be required to do a QQ plot on a small sample at that point?
No,
Because we're making an
I'm
assumption.
I'm telling you in the problem, I told you that the population is normal, right? And the population is normal implies that X bar is normal. Okay. So it doesn't matter how big the sample is. It could be a sample of 2 or 3. It doesn't matter. Yep. If the population is normal, you're guaranteed to have X bar normal regardless of sample size. Okay. Any other questions on that? Okay. Something that I've not mentioned yet, but it's actually important, is the interpretation of a confidence interval. So what I've got up here is the interpretation of a 95% confidence interval from you, but this just, could be any other type of confidence interval or any other confidence level. So that's not the important thing. This is not in the notes, this is just something I put together. But when I scan these and post them, it'll be in there. We can write it down however you want. So what people commonly do when they're trying to interpret a confidence interval, if I give you a value, give you an interval from you, this is a really common interpretation. They'll say, oh, okay, I've got this confidence interval. There must be a 95% chance that mu is in that interval. Makes sense, right? Right?
Yeah.
Well, the bad news is that's wrong. So this first one is wrong. What's wrong with it?
You're not saying that there's a 95% chance. You're saying that it may fall within that 95% parameter. Is that what you're saying?
Well, the issue is this. And it's really subtle, but it's also really important. If we've got a population, what does mu mean? What does mu stand for? Mu is the average of that population. Does that change? No. Mu doesn't change, does it? Mu is a fixed value. We don't know what it is, but it's fixed. It's some fixed, unknown value. So mu doesn't change. So if I give you an interval like 2 to 3, either mu's in that interval or it's not, right? If mu is 1.5, if mu's 1.5, it's not in the interval. If mu's 2.5, it is in the interval. It's either in there or it's not. So to say there's a 95% chance that a fixed value is in that interval is wrong. Right? It's either in there or it's not. Either it's in the interval, it's contained in the interval, or it's not. So you can't say there's a 95% chance. The thing that's wrong with this is you're treating mu like it's random. Mu's not random. What's random? The endpoints of the confidence interval. If I give you a different sample, when you calculate your confidence interval, isn't that going to be different? You're going to have different endpoints on your confidence interval, aren't you? Yeah. So the correct way to interpret this, but it's kind of hard to think about. The second one is, if you were going to interpret a confidence interval, would be the correct way to do it. You'd say, in repeated sampling, 95% of the intervals constructed in this manner will contain mu. Right? So you can think about this in terms of a picture. So if this is our population, we take a simple random sample, and once we get our sample, then we can get a confidence interval, right? So you get some confidence interval. Well, we could do that again, couldn't we? Couldn't we take another simple random sample from that same population? We could. And if we have a different simple random sample, isn't this confidence interval here going to be different? So we have a confidence interval here, we have a confidence interval here. You can keep doing this as long as you want, right? So dot, dot, dot kind of to imply you do this a bunch of times. So what this says, in repeated sampling, so you take one sample, then you take another sample, then you take another sample, you take another, you keep doing this over and over. If theoretically you were able to do this a bunch of times, 95% of these confidence intervals would be correct, and 5% of them would be incorrect. That's kind of the theoretical interpretation of what a confidence interval is. The way to remember it, or the way to think about it, is we're not 95% confident, we're 95% confident in our method. We're not 95% confident in that particular interval per se, in those particular numbers. We're 95% confident in our method. Does that make sense at all? It's really subtle, but it's probably important that I say that. So if you've done some research and you're looking at an article and somebody does a confidence interval in the article, when you interpret it later, or if you're creating a confidence interval for some paper you're doing or something, anytime you interpret that interval, it's wrong, and some people will really jump on this, and some people may not even know the difference. But some people will really, if you say, oh, there's a 95% chance that mu is in this interval, some people would pick up on that and be really offended. Not offended is probably not the right word, but some people would really pick up on that and not like it, possibly. So just in the future, stay away from that first one, because some people really dislike it when people do that. Okay, so that being said, the next thing I want to talk about is something that I mentioned yesterday, and I think somebody had a question about it. Said, well, how can we get summary stats? So let me talk about that. When I say summary stats, I'm talking like getting N, getting X bar, getting S, those kind of things. I'm going to show you 3 ways to do it, and I'm not going to spend a lot of time on any one of them. This, again, is not in the notes. But once I scan this, you'll have access to it. All right, so how to get summary stats, N, X bar, S, etc. in a TI 83 or 84, so a TI graphing calculator. If you've got an 89 or a different version, this might work a bit different. Many of you guys have already done this probably. If you don't have a TI calculator and you don't ever plan to get one, then it doesn't really matter. But basically all you do is put the data in a list, and then there's a function called one variable statistics. Oh, it's covered up right now. That just gives you n x bar s. It gives you the median and some other stuff as well. I can do this with the data set that we had yesterday, maybe. And I wouldn't bother writing this down unless you know that you're going to use it. This will be posted online, so you could go back and review it there too. So I know there's quite a bit of writing. And like I said, I'm going to scan this and you'll have access to it. But basically what you do is you go to Stat, Edit, and there's the list editor, and you can enter all your data there. And then once you do that, you do this function called one variable stats. So let me show you. Here's my TI. I go to Stat, Edit, and this is the first list. It's called L1. I can enter my data there.
How do you delete them if you have something?
If you've got something there, you push the up arrow. Like let's say I've got 1, 2, 3, and I want to get rid of that. So the way I do it is I push the up arrow, I push clear, and then I push enter, and now it's gone. The data's gone.
Oh, okay.
So let's do the data set that we had yesterday in that last problem. So that data set was 18, 19, 19, 25, 20, 36, 30, and 24. Wasn't that the right one?
Yeah.
So I put that data into L1, and now what I do, once I get the data into L1, I do stat, calc, one var stats, enter, and then enter. So I do stat, calc, so I have to arrow over to calc. And notice there's this function called one var stats, so I hit enter, and then I have to hit enter again. And notice what that does. It gives me x bar, it gives me s, it gives me n. If I scroll down using the down key, it can give me the min, the max, it gives me the 5-number summary and all that kind of stuff. So that's a handy function to have if you've got a TI with you. Yesterday when I was doing this, I did this in R. I don't know if you guys noticed what I was using. Maybe you didn't. R is something that I've been using kind of off and on throughout the semester. And R is a full-scale statistical package. You can do basically anything you would ever want to do in statistics in R. That's the good news. The other piece of good news is it's freely available online. So you can go online and download it to any computer, any platform you've got, whether you've got Mac, Linux, Windows, whatever. The trade-off is it's a little bit tougher to use, I think. So I don't really use it very much here. I'm going to go over it just because if you're trying to do some of these homework problems at home or something, if you don't have Stata at home because Stata is expensive, you don't have a TI at home, maybe you want to be able to do some of these and you could try and use R to do it. If you want to download it, this is the website. It's free to download. What I'm doing here is defining a variable. So I'm calling this variable var1 equals, this is a lowercase c. The C stands for, I believe it stands for a column, because when you have a variable, usually it's a column of data. And so we're just defining a column of data, and then you just enter the values separated by commas. And then if you want the mean of that one, you do mean parenthesis var1. To get S, you do SD parenthesis var1. If you want N, you do length parenthesis var1.
Would it like matter if the numbers were like from lower to higher or higher to lower?
No, the order you put them in does not matter. So show you that quickly. So this is our so what were those numbers again? Can somebody read them off to me? 19, 19,
25,
25,
20,
20,
36,
36.
30, 20.
At 18.
Where's 18? Oh, at the beginning, yeah.
All right, so did I get them all here?
Yeah.
19, 19, 25, 20, 36, 30, 24, then there was an 18 in there. So the order you put them in doesn't matter.
Oh.
Yeah. So now I hit enter. All right, so it has var1. So if I type var1, it'll show me those values back. So if I want the mean of var1, I type mean, parenthesis, var1. And the mean is 23.875. If I want the standard deviation, I do SD, parenthesis, var1. If I want the number in there, I do length, parenthesis, var1. So that's all I do, and that's I think, pretty easy. The other thing that we're going to possibly want to be able to do is to get a QQ plot, right? So QQ plots are something that we might want to be able to look at. All I do is type QQ norm, and this is on those notes as well, var1. QQ norm var1. Oh, that's what I did. So it gives me the QQ plot. Notice it doesn't have the line. If you want the line, you have to do that separately. So you go back and you type QQ line var1, and it'll add it. So this is a QQ plot. So you're able to do that, and you know, if you're doing this at home or something, this might be something that's handy. I'm never going to require to use R because I know it's a bit more complicated. So that's what I have here. So if you want to get the QQ plot, you have to type both of these, QQ norm var1, then QQ line var1. Stata, I don't remember how much we've used Stata. I don't think we've used it a whole lot, but we will. Especially in Unit 4, we'll use Stata a little bit more. In Stata, this is what you do. You go open up a data editor, and you just type your values in the first column. And then all you have to do is type summarize var1, and it'll give you those. So I'm going to open up Stata. This is what Stata looks like. Well, let's check for updates later. Okay, so do data editor, edit. And what that does is opens up a little data window, and all you do is type your values in that first column. So can you guys read those to me again? 18, 19, 19, 20, 25, 36, 30, and 24. Okay, so these are my values. Once you type them in, go ahead and close that data window. Now just type summarize, S-U-M-M-A-R-I-Z-E, space, var1, and it gives you the number of observations is 8, this is the mean, this is the standard deviation, this is the min, this is max. So that's pretty easy to do, I think. And you might also want a QQ plot. In this one, you type Q norm, space, var1. And that will give you a QQ plot. So I'm giving you more information here than you probably want, but it's all there in case you, depending on which method you want to use. All right, so this is the QQ plot. Any questions on that? Like I said, I'll scan those and post those so you'll have access to them. And yeah, just for the sake of completeness, to get the QQ plot, you type Q norm space var1.